Here's an example based on income levels and the poverty line. In this example, we know the mean income per capita, and we know that it's normally distributed, and the standard deviation is given. And the first part of this is saying that if the poverty line is this much, what proportion of the population would we expect to be defined as poor? And this kind of question is based on the assumption that you've got a normal distribution. So if you've got a scale of income across here, so that's income. Then there's some average level of income, which here is 320. And there's lots of people at that average level, and there's a few people above, a few people below, but the further away you get from the average, there's fewer and fewer people that have that. We're assuming actually that the whole pattern, if you did a histogram, it would work out looking something like this. Which means where I've drawn it, the actual means there. So if you did a histogram, it would have this kind of shape. It's a normal distribution shape. And we know that we've got a mean of 320, which we can label in here, 320 shillings, and that's often given the symbol mu for mean. Now when you're doing this kind of problem, it's a good idea to look into the numbers and see what number stands for each part. So this part here, that's our mean. And we got this number here. Oh, we got this number up. Oh dear, that was a bad idea. This is a very powerful eraser. Got this number here is the standard deviation. And that's telling us about the spread. Which means the spread from side to side. And as I tried to tell you, or as I've mentioned in some of my lectures, that with the normal distribution, you can see here it's curving that way, and here it's curving that way. But at the bottom it's curving this way. And it's just at the point where it stops curving like that and starts curving the other way, about here somewhere, that distance is the standard deviation. So that distance there is sigma, which stands for standard deviation. Oh, I've got a slightly different colour. Never mind. That's sigma. So that measures this probability. The bigger this number is, the more spread out it would be. So those are the two numbers. The other number we got is this 350 here. Now the 350, this is sort of the number we're interested in. And these kind of problems, you can call that anything. Often in formulas that's called x, the number we're interested in. So because it's 350, it's bigger than this one. It must be here somewhere. So you can label that as, let's exaggerate a bit and say 350 is here. And that's x. And then finally, what's the question asking us? It's asking us, what proportion of the population is defined as poor? Well, poor is anyone that earns less than this. So anybody that earns any amount of money down here, that's poor. So what we're trying to find is what percentage of people are here in this area. That's what this is asking us. And wants to know what percentage is that. Yeah. Now, because it's a normal distribution, we can find this out if only we can find out how far above the mean this point is. Then we can tell exactly what percentage this is by looking it up in Excel. And what you need to know for Excel is you need to know not how far above that is, because obviously this is 30, but you need to know how many standard deviations is it. So how many standard deviations is it from here to here? And because the standard deviation is 28.3, it's going to be less than 1. Shows I haven't done the scale very well, never mind, because this point should be less than that far. So the formula for, if you like formulas, the formula for, we'll stick with pink, okay, pretty in pink. The formula for the z-score, which is the number of standard deviations, is the number you're interested in, subtract the mean, and then divide by the standard deviation, sigma. So that's this minus this divided by the 28.3. So it's 350. Minus 320, all divided by 28.3. Okay, which is 30 over 28.3. Only two equal signs. There. Now, unless you're very good at calculation, you can't do that exactly in your head. That's 1 point something. So we'll grab hold of our friendly calculator. Hopefully. We'll put in 30 divided by 28.3. 1.06, so about 1.06. Yeah, 1.06 is pretty accurate. Now he wants to know, for a z-score of 1.06, so 1.06 standard deviations above the mean, what proportion of the population is less than that? We can answer that either by looking in tables if we're a bit old-fashioned, or we can go to Excel. Remember, this spreadsheet will do it. It's this one, this way round in our Excel spreadsheet. How many standard deviations above the mean are we? Well, we're 1.07. Or was it 1.06? My memory is extremely short. 1.06. That's the z-score, and using this formula, norms dist of 1.06, the built-in formula in Excel looks up that number and gives you the answer 0.855. So the conclusion for part 1 is that 0.855, which is the same thing as 85.5% of the population are poor, or defined as poor. And that's part 1. So really, apart from the long-winded explanation and diagrams, it's very quick to do. The key stages is knowing what a z-score means, knowing which numbers are which. This is the mean, the standard deviation, and the boundary that you're interested in here. Putting the things into the formula to work out how many standard deviations you are above the mean. Putting that into Excel or tables and working out the answer. Okay, there's no further complex stuff is needed for part 2. If we chose one person at random from this area, what's the probability that they're not poor? No, what's the probability they come from this part here? And the probability they come from this part here. So let's find a number we have. Okay, we've used green. 2 is asking us what percentage is in. So the probability is the same as the percentage that are in this area here. So if the whole population is 100%, so it's 100 minus 85.5. Carry on this nice pink. Equals 14.5% is the probability that the person is not poor. And this says probability for those of you that can't read doctor's handwriting. So 14.5% is the probability that if you pick a person at random from that village, they won't be poor.